Your phone unlocks with just a glance, right? In less than a second, it feels like pure magic. But what's really happening in that blink of an eye? Well, today, we're going to pull back the curtain and go inside the machine to find out. You know, that split-second unlock isn't magic at all. It's actually a breathtakingly fast and super precise sequence of events. It's a journey that transforms your face from a simple picture into a unique digital key. So how on earth does it work? In our last explainer, we talked all about how a computer even learns to see a face in a sea of pixels. If you missed it, check it out. But now we're going deeper. We are going to follow a single image on its incredible journey from the camera lens all the way to a confirmed identity. This whole thing can really be broken down into a 4-step journey of transformation. Think of it like a highly engineered assembly line, one that takes a raw image and forges it into a verifiable identity. So here's our roadmap for that journey: detection, alignment, feature extraction, and finally matching. Now, what's really cool about this is that this pipeline kind of mirrors how our own brains work. First, we spot a face in a crowd, right? Then we focus on it, we recall its unique features, and only then do we confirm who it is. The machine is following that same logic, but with pure mathematics and at pretty much the speed of light. All right, let's kick things off with the first 2 stages. These are all about prep work, because before a system can know who you are, it first has to find your face and get a perfect, standardized look at it. First up, you've got detection. Imagine a digital searchlight scanning every single pixel of the photo. Advanced AI models are basically hunting for those specific patterns that just scream human face. Once one is found, bam, the system draws a precise digital frame around it. We call it a bounding box, perfectly isolating your face from everything else in the background. Next up is alignment. I mean, in the real world, nobody looks at a camera perfectly straight on every single time. So the system becomes this little digital artist. It automatically rotates, scales, and adjusts the face it just found. It's exactly like carefully straightening a tilted portrait in a frame, just to get the absolute best, most direct view possible. This whole crucial step, it's got a name: data normalization. And this really gets to the heart of it. It's all about quality control. By standardizing the face, the system strips away all the temporary stuff, like a slight head tilt, a weird angle, or bad lighting, so it can focus only on the permanent, unique features of your identity. Okay, with the face perfectly framed and standardized, we've arrived at the heart of the entire process. This is the most powerful part of the journey. This is where the visual data of your face gets reborn as a unique mathematical identity. The goal here is pretty wild: to translate your face from the language of pixels into the language of mathematics. That perfectly aligned image gets fed into a deep neural network, which acts like this powerful distiller, boiling down millions of complex visual details into one simple, elegant, and powerful numerical signature. And that signature has a name, an embedding. And that's all it is, really. It's just a string of numbers that serves as your face's unique digital fingerprint. All the complexity, the nuance, the character of your face, all of it represented as a single vector of data. So how does the system organize millions of these fingerprints? Well, picture this. Imagine every unique face is a single point of light in a vast, dark galaxy. The AI's job is to arrange this galaxy so that different photos of the same person, you for example, get pulled together into a tight, glowing cluster. And at the same time, it pushes all other faces, all those other points of light, far, far away. Okay, let's move to the final stage and see how this all comes together. We have that unique numerical fingerprint. Now, it's time for the moment of truth, making the match. This final step is kind of like a handwriting expert comparing 2 signatures. They might not be identical, right? But they share a unique, recognizable style. The system takes the new embedding it just created and mathematically compares it to the one it has stored in its database. It measures the similarity, and if they're close enough, it declares a match. Now, this matching happens in 2 main ways. On the left, we've got verification. This is a one-to-one check. It's asking a simple question: are you who you claim to be? That's your phone unlock. Then on the right, you've got identification, which is a one-to-many search. It asks a totally different question: who, out of everyone I know, is this person? That's how social media suggests photo tags. 2 different uses, all powered by the exact same pipeline. And that's it. That's the 4-step journey. from a camera lens to a definitive answer, all happening in a fraction of a second. This is how abstract code becomes a seamless, invisible part of our everyday reality. And this entire lightning-fast pipeline, detection, alignment, extraction, and matching, this is the engine behind so much of modern life. It's what unlocks your phone, automatically tags your friends in your photos, gets you through those automated airport gates, and underpins so many modern security systems. When you really pause and think about it, it's pretty extraordinary. Every single time you unlock your phone with your face, you are witnessing a silent and visible masterpiece of computer vision and pure mathematics playing out right there in the palm of your hand. So the next time your device recognizes you instantly, just for a moment, remember what's truly happening. Because behind that effortless convenience lies a machine's silent, complex, and deeply mathematical understanding of who you are. But this incredible power also comes with some really profound questions. What happens when this technology intersects with human bias, our fundamental rights to privacy, and all these complex ethical dilemmas? Well, that's where we're going in the final part of our series. You are not going to want to miss it.